Okay, listen up. So, new students, you will need to get your maths book. So I'll have to give that to you later this week. Okay. Listen up now. Listen. The same. Listen up now. So, as you were saying earlier, you were asking me how many methods there are to solve quadratic. So we have factorizing, complete the square, and now we have a formula. Yes, yes. Quadratic formula. Now, please note, most places call it the quadratic formula, although in Ireland and maybe in other places you might hear people calling it minus B formula. I have no idea why, but I'm just telling you this in case you're watching a video or you're reading some notes online or something. It's just another way. The minus B formula or the quadratic formula. Yep.
We use the minus B plus minus 30%.
Yes, that's exactly what we're going to do. Okay, so let's have a look at that now. So we want to try and find a formula to solve this. Okay, so let's try to simplify it. We're trying to find our own formula here. So I should divide everything by A first. Now let's complete the square. So you recall for completing the square, it's half of this number, so that would actually be b over 2a squared. And then what do I put at the back? I put this number minus the square of this number. So that's b squared over 4a squared equals 0. I'm doing completing the square. Just looks more difficult because there's no numbers, but it's still completing the square.
So how do you get b squared over 4a?
That's this middle piece here squared.
Oh.
Yeah. It's the same, it's just this isn't a single number now. That's the problem. Okay, so what I'll do next, x plus b over 2a squared equals b squared over 4a squared minus c over a. Now if you look at that, you'll realize that this here and this here, they're almost the same. So what I'll do to make them the same is I'll multiply the top by 4a and I'll multiply the bottom by 4a, making 4a squared. Now that the denominators are the same, I can bring them together. We're getting to it, yeah. Yeah. So, square root now both sides. And I'll end up with x plus b over 2a equals b squared minus 4ac with a square root around it. All over. Now this is nice because square root of 4 is 2 and square root of a squared is a. So I have x equals minus b over 2a. Oh, I haven't said it, but really I should have plus or minus here. Remember, we have two choices. Plus or minus square root b squared minus 4ac all over 2a. And again, the denominators are the same. So we arrive at our formula. X equals minus b plus or minus square root b squared minus 4ac all over 2a.
Can we do it like when solving the quadratic step by step, finding the discriminant, which is the square root of the...
Yeah, some people like to find the what we call discriminant part first and then plug it into the formula. That's fine if you want to do that. We haven't talked about discriminant, that's actually the next lesson, but yeah, that's fine. There's no problem with that. Yeah?
So, why do we draw limits to just find the equation?
Why do anything in maths?
No, but what's the point of this?
Yeah, we just points and then
It's for your general improvement,
General knowledge.
general knowledge,
But it's like, you know,
enhancing your mind. You don't want to enhance your mind?
Too much
Too much already enhanced enough? True, in the exam they won't ask you to prove it, but I think it is good to see where things come from. They don't just fall out of the sky. Okay? So it is good to see where things come from. And, you know, it's good discipline too, because in the next semester things are more difficult, okay? So it is good if you, the more you practice your algebra, the better, okay? So really this is just a lot of algebra. The more you practice your algebra, the better, okay? So let's have a look at some examples now. So yes, this is the famous quadratic formula. Infamous quadratic formula. Now proven. Okay. Can I scroll down?
do you just think,
1 second? Okay. Oh, and because this is the x equals, these solutions, as we know, are called the roots. Because it's actually the x equals. It would be the points here and here.
And there might be two of them because of the plus minus.
Oh yeah, and again, that's something we'll discuss next time, the different situations. Okay, can I scroll down now? Yeah, so let's have a look at some examples. So our first example is solve or find the roots. This equation, 8x squared plus 2x minus 15. So we'll just use our formula. A equals 8, B equals 2, C equals minus 15. So x equals minus b plus or minus the square root of b squared minus 4a, which is 32, times c, which is minus 15. So there's actually two minuses there. All over 2a, that's 16. Now if you want to do it more step by step, that's fine. Minus 2 plus or minus, what's that? 320 and 160. So 480, 484? Is that right? Yeah.
It's a bad example. You can't take it.
No, it's not. It's typical in the exam to have decimals. Okay, so give me the minus one first. What's minus 2 minus root 484 over 16? And then give me the positive one. Minus
1.49.
1.49, yeah, 1.5, okay. What did I go with at the back? Wait, hang on. I have it as... I wonder if that's a mistake. What did you say, minus 1.5?
yeah.
I think that 484 has an exact square root. What's the square root of 484?
No, there is no 432.
22. Yeah, 22. So I get minus 2 plus or minus 22.
Yeah.
Oh, great. Over 16. Okay. So if I take the minus 1 first, I'll get minus 24 over 16. Minus 3 over 2. And then if the plus 1 would be
5
5 over 4?
Yeah.
Okay. Right, so in this, it looks like in question 1, I made the answers so that they work out as fractions. Okay. Write that down, please. Did you write it down, Mohammed? Yeah? Yeah, ask me. What?
No, I'm just asking you like, no, it's the same. I just guess. It's like if it's minus 2 plus 22,
Yeah.
and if like 20 over 60.
Yeah.
Yes,
It's the
the
same.
same.
Yeah. Okay. Can I go on to the next example? Yep. Okay, so next one now. Same one, except the answer doesn't work out as nicely. And in the question, I tell you to write the answer in this form in the question. So let's see what happens here. A equals 1, B equals minus 16, C equals minus 14, X equals minus B plus or minus square root B squared minus 4AC, 56 over 2A. No, that's a plus, isn't it? Minus and minus. Okay, so I get, oh please check on your calculator if those numbers are right. 16 plus or minus square root 312 over 2. I think that's right, yeah? Yeah. Now, if you type in square root 312, yeah, it's not exact number, it's a decimal. Now, we need to simplify. Remember our lessons on surds? So, if I have 312, no, but we need to show our work.
Do we?
Yeah?
In the exam, not sure.
So what?
How to simplify this? Yeah. No, I don't want that. Shh. Hey, listen. Note. Hey, the same. Note. I am doing this without a calculator. So, when you type in root 312 and you get the simplified form, okay, you cannot just put that in. Okay? You're supposed to try, except for the first question with the decimal. No, not even that one. Yeah, question 1 and 2 is supposed to be done without the calculator. Well, I mean, of course, you can use your calculator, but you can't use your calculator to skip any steps, just to help you. Okay? So the 312, I need to simplify it over here. So 312, 2 and 156. And 52 by 3. 26 by 2. Okay, and then this is 13 by 2. And there's a 2, and there's a 3, and there's a 2. So what's that? That's 2 squared multiply 2 multiply 3 multiply 13. So when I do a square root here, what am I left with? 2 root 2 by 3 by 13. What's that? 17?
78.
That's better. 78, yeah. 2 root 78. Now I can go back and put that in. 16 plus or minus 2 root 78 over 2x. Okay? What's in common with all of these 3 numbers here? 2. So you can divide everything by 2, and you get x equals 8 plus or minus root 78. And that's the answer.
Shouldn't we put it as a decimal? Or
No, not in this case, because the question says they want the answer like this.
So with family, let's draw that tree for root 312.
No, it doesn't have to be this tree, but I want some evidence of workings. So, for example, you could write down here, if you could see it directly, 4 times 78, which is 2 root 78. But I mean, it's difficult to see this without drawing the tree. But to answer your question, no, you don't need the tree, you need some workings, some calculations.
So this proof is 4 times 78 is fine.
Yes, yeah. And then the 4 comes out of the root then, yeah. Okay. Next one. Yeah. Now the next one is the one where we use our calculator, but there's some vocabulary with it to do with decimal places and significant figures. Okay, can I scroll down? Yeah. So just to clear up, if I have something like 5.2356, and I say I want that to 2 decimal places,
5.24.
these are decimal places, and this is 2 of them. So it will be 5.24, because that one, what's the verb here? Round up. Yeah, round up. Okay, so what would this be now? To 3 decimal places. 5.236, yeah. And then let's say 0 decimal places. 5. Okay, so that is decimal places, or DP for short. Decimal places.
What if we would have, instead of 3, we would have 7?
Yeah, so
Then to 0 DP.
5 point, which one?
If we, instead of 2 or 3, we would have, I don't know, 5, 5.
Yeah, 5, and yeah, and how many
to 0 decimal places? 6.
Yes, you're right. So this one here, that's 6 to 0 decimal places. To 1 decimal place,
5.6.
2 decimal places, 5, and then 3 decimal places. Yeah, so still just 5. So 0, 1 decimal place, 2 decimal place, 3 decimal place. I remember this was a little bit confusing in the physics class. They're actually, in this case, the same. 2 and 3 decimal places. That's decimal places. But this is something that everybody learns in middle school. Okay? The next thing, which is maybe something you're not familiar with, which is called significant figures, SF. Okay, so 42.613. If I say 1 significant figure, what I mean is the first number. I only want that one. So that'd be 40.000. In other words, just 40. Okay. If I said 2 significant figures, not 42. 43, because this one would make it round up. 3 significant figures, 42.6, and then 4 significant figures, 42.61, and then 5 significant figures, 42.613. Now you have to be careful if it starts with a 0. Okay, so I'll do that one next. So decimal places and significant figures. I think in the exam they might use DP and SF, or they might write the word.
They usually in the beginning of the exam they ask to round up everything to.
It does say that in the exam, yeah, on the front, but sometimes in the question they ask for a different number. Okay, let's look at ones that start with 0. Do you have that? Well, it's only a bit of scratch notes. Okay, so if I had 0.001234 and I said 1 significant figure, you don't count the zeros at the start, so it actually would be 0.001. If If I said two significant figures, that would be 0.0012. How many decimal places is this? This is actually 3 decimal places. And in this one, by the way, it is 4 decimal places. Okay. Now, let's say I had something like 0.0101. And if I said one significant figure, what would that be? 0.01. And then 2 would be 0.010, which is actually, it's the same. In this case, it's the same, okay? So just be careful. You know, sometimes they might ask for example, 2 significant figures, and your answer looks the same as one significant figure. That's not wrong, okay? That happens sometimes. Yeah. Let's do one more. 100.001. And if I said 2 significant figures, what would it be here? 10?
It's 100.
Like 10? What number?
It's 100.
It's 100. You're right.
10.
2 significant figures here would be 100.
10 to the power.
Yeah. Would actually be 100 here. Yeah. 2 significant figures, okay? Because this counts as the first and this counts as the second, even though it's a 0, because it came after the first number, okay? But if I had a 0 here in the front, do you count this one? No. You only count these ones here. Okay? Yes? Yeah, we don't actually really use the scientific notation for the maths class, yeah. I maybe use that in chemistry, I'm not sure. Anyways, you don't need to worry about that. So just to summarize here, you have a number a dot b. Decimal points means you start counting from the decimal point out, okay? And then if you have a dot b, significant figures means you start counting from the first non-zero number. And then you start counting. Okay, so let's use that now. If you look at question 3, you see I tell you how many, or what I want. So like, first one is 2 decimal places. So let's try that one. Minus 9x squared minus 6x minus 1 equals 0. Okay, now you can use your calculator fully. So I want you to tell me the answers to 2 decimal places here. Say again? It would, yeah, this is 3a. It's solve, and then here it's 2 decimal places. First one is what? Oh, it's the same one for both actually?
There is just one root.
Oh, it's just one root here because both of them are the same.
Discriminant is 0.
Yeah. So we don't need to say that.
So you have to use the minus b method?
Yes, yes, all questions for this one.
This one.
How many of them should we do?
Let's see. Well, I want to, for the last one, I want to make sure I get a good mix here.
So from number 3, how many?
Yeah, just a sec now. Okay. So let me just tell you which ones you need to do from this lesson. From number 1, yeah, X, Y, Z. From number 1. And then from number 2, M and O. But from number 3, let's see.
ENU.
No, hold on. Hold on. I want 2 decimal places and 2 significant figures. So we could say BC, and then another, and then HI.
That's it.
Now, also,
Do we have to do 4 and 5?
yes, I would like you to try 4 and 5. But don't worry, it's optional, okay? But I would encourage you to try 4 and 5 as well.
Can you repeat the rule? What's for?
Yes, so I'm saying it again. Listen. Number 1, X, Y, Z. Number 2, M, N, O. Number 3, B, C, H, I. Yeah. And then 4 and 5 if you can. Yes? Question? No? Okay, so you can start your homework now from both lessons. And in fact, you might get it all finished actually, because you've got about 20 minutes. Okay, so you can work on that now.